Comets. Comets are tiny bodies that orbit the Sun and contain a significant amount of volatile ices. A coma, or dazzling outflowing atmosphere surrounding the comet nucleus, is created when a comet approaches the Sun and its ices sublimate, transform instantly from the solid to the gas phase. The comet develops two tails, one made of dust and the other of ionized molecules and radicals as the gas and particles in the coma freely flow into space. The Greek letter rho, cometes, which signifies long-haired, is where the word comet originates. The typical observational test for determining whether a recently discovered object is a comet or an asteroid, in fact, is the presence of the brilliant coma. With their dazzling, luminous comae, their long dust tails, and their extended ion tails, comets are among the most magnificent celestial objects. Comets can emerge out of nowhere and can be seen for months at a time as they travel in very eccentric orbits around the Sun, giving off a spectacular and constantly changing spectacle. Because comets are primitive bodies left over from the creation of the solar system, they are significant to scientists. They were some of the first solid objects to emerge in the solar nebula, the interstellar cloud of gas and dust that collapsed and gave rise to the Sun and planets. The solar nebula's outer portions were sufficiently cold for volatile ices to condense, which is where comets formed. The accepted definition of this is that it lies beyond the orbit of Jupiter or 5 astronomical units, 748 million kilometers or 465 million miles. Comets have not undergone many of the modifying processes that have melted or altered the larger things in the solar system because they have been kept in far orbits beyond the planets. The processes involved in the formation of planetary systems and the primordial solar nebula are thus preserved in their physical and chemical makeup. Comet nuclei have been extensively studied by telescopic studies from Earth and spacecraft missions to comets. Small solid structures called cometary nuclei are made up nearly equally of volatile ices, fine silicate dust, and organic components. They typically have a diameter of only a few kilometers. Water ice makes up the majority of the ices, approximately 80% of the total, but there are also ices made of carbon monoxide, carbon dioxide, formaldehyde, and methanol. The silicate and organic composition is comparable to that of carbonaceous chondrites, the oldest type of meteorite. At microscopic scales, the materials are thoroughly blended. 1 micron is 1/millionth of a meter. 4.56 billion years ago, as dust and ice particles accumulated in the solar nebula's central plane, the solar nebula's nuclei began to form. They tend to cling together after colliding. Through this process of agglomeration and accretion, micron-sized particles develop to meter-sized and eventually kilometer-sized bodies.